So we're going to look at the other one that's calculator active, and then next week we'll look at the one that's not calculator active, okay? So how do you know the difference? It's got the calculator not marked out. So this is the second one that you took. It should be turned in already. And then it said the statistician performed a linear regression. That means that they put it into stat. So I'm going to get my calculator. I'm going to turn it on. And I'm going to go to stat and edit. And you guys know how to do this. We've done this multiple times in class. Type in your numbers. Make sure you have L1, L2. If you don't have L1, L2, then you have to reset your calculator. Okay. Then 11.0, 16.5, 19.2, 23.1, 24.3, 29.5. Once you get all of your numbers in, make sure you go back and kind of check them so that you didn't type anything in wrong. 2.3, 4.2, 5.1, 6.4, 8.2, 8.5, 11, 6.5, 19.2, 23.1, 24.3, and 29.5. Okay. Once we get there, we're going to go to stat and calc. Anytime it says linear regression, stat, calc, and linear regression. We're going to hit enter. And do you guys remember how you get that R in there? Because when you get your calculators, it won't be there. Do you remember what you have to do to get the R? When we go to mode right here, you want to make sure that your stat diagnostics is on. Okay, so you might want to write that down. Stat diagnostics has to be on, otherwise you're not going to see the R. And that'll come in handy eventually. So I'm going to go back, stat, calc, linear regression, so that you guys can see the R. All right, so this is what it said. The statistician performed a linear regression and also plotted the residuals. We don't care about the residuals, so don't worry about that right now. Based on the residual plot, the statistician decided to exclude one data point. Those points that he chose to, one of these is what he chose to exclude. He then performed a linear regression. That's what we just did. The result was that the new linear model fit the remaining data more closely. So right now, with this data, and I'm going to write this number up here. Remember, R tells us how good it is. So right now, it's 0.973 or 0.9728. I don't care what you write. He took one of those points out and it got better. So we're going to take those points out. We're going to see which one gets better. That's all you do. Okay. So let's check this out. We're going to start with the first one. We're going to go back to stat and edit, and we're going to take out the first point. Now remember, once you take it out, you're going to have to put it back in eventually. Okay. So then we go to stat, calc, linear regression. Is your R value better or worse? Remember, we want to get close to 1, right? We had 0.97. That's what we had. Which one's closer to 1, 0.97 or 0.94? Yeah, so this one did not make it better. Okay. So now I'm going to go back into stat and edit. I'm going to put that point back in. It doesn't matter where it goes. I'm going to put it at the bottom so I don't have to screw anything up. And now I'm going to take out 4.2 and 16.5. And I'm going to do the same thing. Stat, calc, linear regression. See if it's bigger than 0.97. No, right? It's not. So it's not this one either. So I'm going to go back into stat and edit. I'm going to put that point back in. 4.2, 16.5. And then I'm going to take out 6.4 and 23.1. I'm gonna do it again. Stat, calc, linear regression. Remember our other one was 9.73. What's this one? Sorry, 0.973. What's this one? Is that better? It looks better, right? Let's check the other one just to make sure, just in case I screwed up. So I'm gonna put that 6.4 and the 23.1 back in, and I'm gonna take out 8.2 and 24.3. Run it again. Ooh. What about this one? Which one would be better? Yeah, so you gotta watch plugging in. You gotta watch it. Any questions? All right. We'll get number 2. Yeah, hot. Is it hot in here, y'all? Not at all. I'm gonna sweat to death. All right. All right. 9 data points are shown below. Which statement is true if the 10th data point is added to the data set? It's asking about the mean and the median. Where do I do that at? Where do I find my mean and my median? How did I do that in my calculator? You can, but I can do it in my calculator so they don't have to keep typing it in. Do you remember how we did it? You guys just did it right before Thanksgiving. It's kind of the same thing that we just did. We just use L1. So remember to find mean, median, mode. We go back to stat and edit. And we don't need anything in L2, but we're going to put everything in here. 8, 11, 12, 10, 9, 7, 5, 3, 9. And it said what happens when I put that data point in. So I need to know what happens before. So to find your mean, median, and mode, you put it into L1. You go to stat, calc, and number 1, that 1 bar stats. You guys will see it'll give you your mean is 8.2. And then if you go down a little bit, your median is 9. So that's all I put on there. I just wrote it down. So then it says, what happens if I go back and add 45? So I'm going to go back to stat and edit. And I'm going to add 45. And I'm going to do the same thing, stat, calc, 1. What happened to your mean? It went from 8.2 to 11.9. What happened to your mean? So your mean increased. What happened to your median? Read your answer choices. Mean and median both increased. We know it didn't. The mean increased. The median decreased. What did the median do? Stayed the same. The mean will increase and the median will remain the same. The mean and the median will both decrease. That's it. So make sure you use that calculator. Any chance you get, use calculator. Okay. I'll flip it over. Let's see if there are any more. Look at number 11. Number 11. It's basically the same exact question, so that's why I'm going to it. We have 8 different bears at the zoo. If the weight of the polar bear is removed, which statement is true? The mean decreases more than the median, the mean, the median, blah, blah, blah. So the first thing we need to do is find it with the polar bear and then find it without. So where do I go? Come on, guys. Where do I go? Thank you. Type these in. You can type straight over that. You don't have to empty it out. And then you can delete the last two. So 225, 300, 550, 200, 1,000, 300, 280, and 100. And like I said, I'll just go back and check and make sure those are right. Where do I go to find my mean and median? And it's the very first one. And my mean with the polar bear was 369.375. I scroll down and my median is 290. Now we want to take out the polar bear, so we're going to take out the 1,000. So go back to stat and edit. Delete the 1,000. Stat, calc, enter 1,000,000 times. The mean is 279.285. The median is 280. Okay, now listen to what it says. The mean decreases more than the median because the polar bear is a high outlier. Did the mean decrease more than the median? So how much did the mean decrease by? How can we figure that out? So 369.375 minus 279.285 was 90.09. The median was 290 minus 280, which is 10. All right, so which one decreases more? Okay, so this one says less than, this one says less than. The other two say more. Is it because the polar bear is a high outlier or because the high value balances the low value? What do you think? Look at the difference. What's different about the polar bear compared to everything else? He's huge, isn't he? Right? That makes him an outlier. Any number way bigger or way smaller than a lot of the data is going to be an outlier. So your answer for number 11 should be A. Okay. All right, let me look at some more. All right, let's go to number 6. So So anytime you have a chart or a set of data, you're probably going to put it into stat, okay? So anytime you see the word average is the same thing. It says it here too. It says slope is the same thing as slope. So what is the meaning of the slope of the linear best fit line? A lot of times you can just find the slope and you've got your answer. This one we might have to read a little bit. So how do we do that? You put it into stat and you do linear regression, okay? So we're going to go into stat. I'm going to slide this a little bit so my calculator can come to the side. Stat and edit. 10, 20, 30, 40, 50, 60, 70, 80. L2, 62.9, 68.2, 69.7, 70.8, 73.7, 75.4, 77, and 78.7. Again, just check to make sure you type them in right. Sometimes I type them in wrong. It happens. And then you're going to do stat calc, linear regression, because it tells you to. Linear best fit equation, that's linear regression. Which one is your slope? Where do you find your slope in the equation? Say it again. Nope. Remember, we had equations like this, y equals mx plus b. Which one was the slope? Yeah, the number with x, right? In the calculator, it's ax plus b. So it's whatever your a is. So a is your slope. What is b? Your y-intercept, or where you start. All right, so look at our calculator. What's our a, or what's our slope? Yeah, which one says it? Look at it. What? One more time. What'd you say our slope was? Uh-huh. Look at A. Oh, sorry. Which one's our answer? D. Gotta be. Sometimes you'll have to read the sentence and be able to tell, but most of the time you don't. Okay. Show you another one like that. $15. It asks for the slope again. So how do we find the slope? We put it into stat. We're going to type our numbers in. We have 50, 200, 350, 400, 650, delete the other stuff out. 1.56, 10.5, 12, 19.5, delete the other stuff out. 1.56, 10.5, 12, 19.5. Stat calc, linear regression. This time we got our slope was 0.03, but they give it to us in fraction form. We know it's not this one. You guys can either do one of two things. Type in 0.03, math, enter to get your fraction, which is going to be B. Or you can type in all your answer choices. 3 over 400 is not 0.03. 3 over 100 is 0.03. And 3 over 25 is not 0.03. It doesn't matter which way you do it, okay? So just figure out which one is 0.03. All right. Let's see what else I got. check this one out. What's the distance in units between the function, the x squared plus 7x minus 18, and the y-intercept of the linear function that passes through the point shown in the table below? So let me show you this. I am going to show you Desmos. I don't even think I have it pulled up. Do I? Nope. Whoa. Desmos. I'm not sharing anymore. Sorry, y'all. I didn't mean to click it off. All right. So here's Desmos. I'm going to put in that function x squared plus 7x. And the reason I'm using Desmos on this one is because we can see it a lot clearer than we see our calculator. And we can manipulate it a lot easier. Okay, our calculator, we got to like do some weird zoom stuff. I need the y-intercept. That's where it crosses the y-axis. So I can move it so I can see that. Where does it cross the y-axis? What's the actual number? Negative 18, right? So I'm going to go back to my paper for a second so you guys can see it. This one has a y-intercept of negative 18. I can put this one into my stat. I'm going to show you how to do this on Desmos too, but you won't like it as much as you do on your calculator because you already have been comfortable with this. So stat edit, negative 5, 10, 25, 60, delete that out. 2, 11, 20, 41, delete that out. Stat, calc, linear regression. Remember, B is your y-intercept. So what's your y-intercept here? 5. All right, so before I do anything else, I want to show you how to find that on Desmos. It's really crappy to remember. It's not hard, it's just crappy. So you can put a table in. We go to this plus over here and down the table. And you just put your table in, negative 5, 10, 25, 60, 2, 11, 20, 41. And then this is the part that's crazy. You have to remember, it's got to go in exactly like I type it. Y1. And then you'll do shift and the number, the key beside number 1. It's called a tilde. Okay, so it's a little squiggly line. MX1 plus B. MX1 plus B. And then if I go home, I can see my y-intercept now, and it's at 5. Which way was easier? Put it in your calculator because you're used to that, right? So I don't care which way you do it, but it's for me, it's really hard to remember that y1 mx plus b or whatever. So when I start Math 1 next semester, I might start doing that. Probably not. But so you guys know how to do it there as well, but you get both calculators, so it doesn't matter. So what am I doing? Okay, so when we come back, I have 2 of these now. All it wants to know is the distance between these 2 points. So we're talking about on a number line. So here's 0. We got to go all the way to negative 18 to positive 5. So how far is that? How far is it from negative 18 to 0? 18. How far is it from 0 to 5? And then we just add that together. How far is it? 18 plus 5. That's it. That's all it wants to know. That same type of question is on the Math 3 exam. It's crazy, isn't it? Any questions? Everybody good? Not too bad. Let's see, what else can I do? All right, we can do number 8. Abby scored an 87, a 93, 96, and an 89. So think about your grades on the first 4. What score does she need to get on her 5th quiz to have an average of exactly 91? So her average is her mean. Okay, so in this case, the average is the mean. So what I would do for this question is go into stat, take out those L2s, they don't matter, and type in the grade she already has. And then start with question A or answer A. I'm going to do my stat and my 1var stats and see if I get a mean of 91. That's all I'm going to do. So I don't even have to do any work. Stat, calc, 1var stats. Is my mean a 91? Yes. Everybody see that? That should be my answer. Check this out. If I go back to stat and edit, instead of a 90, let's say she gets a 94. Then she gets a 91.8. What did it say? She wants exactly a 91. Got it? If I plug in a 98, and this is just me showing you. So if they are out of order, stat, calc, 1var stats, a 98 gives her a 92.6. That is not exactly a 91. So this is where they're trying to mess you up. Or if they get 100, it's going to be a little bit higher. Stat, calc, 1var stats. And this one gives you a 93. So they wanted exactly a 91, so we're picking 90. Okay. If these were mixed up, just be careful because we want exactly. All right. Hard question? No. This one's pretty easy. Okay. Check out 13. Says the table below displays a walking heart rate and running heart rate. Ooh, we're about to be finished. Of 8 girls in beats per minute. There's the walking and running. Using the linear best fit model for the data, what is the predicted running heart rate of a girl whose walking heart rate is 100? So what they're asking is to find the equation and then plug in. Okay, so find the equation and then plug in. So the first thing we're going to do is find the equation. So we're going to go to stat and edit. We're going to plug all of this stuff in. 66, 72, 74, 78, 80, 84, 86, 88, 128, 136, 134, 138, 142, 146, 148, 152. We're going to do stat, calc, linear regression this time. And we get this real nasty equation, but you don't have to write the whole equation down. So I get 1.04. So it's mx plus my b is 58.84. I wouldn't go more than 2. You'll be okay. And then the second part says plug in. What are we plugging in? It said find out for 100. So where this x is, we're going to plug in 100. So we're doing 1.04 times 100 plus 58.84. And we get 162.84. Look at your answers. Which one is close to that? $163. Is it? All right. Let me see what else. We'll get to that one later. All right, so take a look at number 7. It'll be the last one that I do. You do have an assignment to do so that we can keep going on Monday, but we will finish this up on Monday and then start the other one as well. Remember, you're finished with class on Tuesday. We have a review, more exam review on Wednesday, and then you take your exam on the following Monday. We will have a review on Friday afternoon. It is optional. You do not have to come, okay? But I would like for you to. Got it? It would be smart of you to review Sunday night. Maybe watch that video Sunday night. What? Nope, it's on Zoom. Unless you have Thursday, if you have not Thursday, Friday, if you have an exam on campus on Friday, you can stay for the review in class, but it'll be the same either way. Okay. All right. So number 7 says the choices below are data sets, and the choices W is a constant. Each choice has the same mean. Which choice has the greatest standard deviation? So we haven't really talked about standard deviation, but it's on your calculator. Okay. So don't stress out. It's the same thing. Now, how do we figure this out if there's a whole bunch of W's? Well, the good thing is W is the same exact number, right? W represents the same thing. Plug in whatever number you want to. Okay. So what can we make W? Make a number. Say it again. 7. We'll make it. W equals 7. I just pulled that out. It could be any number. There could be 30 different numbers that you choose. It doesn't matter. So here's what I'm going to do. I'm going to go into L1 and I'm going to put my numbers. The first number is W minus 2. So 7 minus 2. You guys see what I did? You literally just type it in. 7 minus 1. Just W is 7. 7 plus 1. 7 plus 2. I'm going to find my mean and my standard deviation because that's what it talked about. Stat, calc, 1 bar stats. You remember your mean is the first one. It said they all have the same mean, so we don't even really have to do that every time. I'm just reviewing for you. This little symbol right here, this one with the X, 1.41 is your standard deviation. Got it? So now we just have to find the other ones, okay? So now we go back to stat and edit. We picked 7, so we're going to do it again. This one is 7 minus 2, 7 minus 2, just 7, 7 plus 2, and 7 plus 2. Y'all see what I'm doing? You can pick any number you want to, it'll all work. Stat, calc, 1 bar stats. Our mean is still 7. Our standard deviation is 1.78. We want the greatest one, so that already eliminates A. We're going to go back in and edit. This one says 7 minus 3, 7 minus 1, 7, 7 plus 1, and 7 plus 3. Stat, calc, 1 bar stats. What's our standard deviation? It's 2. So it's our biggest one so far. We're going to check our last one. We're going to edit. 7 minus 3, 7, 7, 7, and 7 plus 3. Okay. Stat, calc, 1 bar stats. Standard deviation is 1.89. What's your biggest standard deviation? So C would be your answer. That's literally all you do. Got it? Anytime you have anything kind of like this, you can pick any number you want to and keep it consistent within the problem and you can figure it out. Just kind of like guess and check. Okay. All right. So I'm going to go ahead and stop sharing and stop recording.